So in this question, you have to find the area of the triangle whose vertices are A, B and C, A having coordinates 1, 1 and 2, B having coordinates 2, 3 and 5, C having coordinates 1, 5 and 5. So let us draw a rough diagram, but do care that these are space coordinates of the vertices. So if we have point A, its coordinates are 1, 1 and 2. I take this point as B. It's a rough diagram which has coordinates B having coordinates 2, 3, 5 and C having the coordinates 1, 5 and 5. Now, if with this information you have been asked to find the area of the triangle which is formed by these three vertices A, B and C. Now, in vectors, what we are supposed to do, we can pick any one of the points and we can generate vectors from this point pointing towards the remaining 2 points. Like suppose if I pick point B, so from B I have to write vector which is pointing towards C, and from D again I have to write a vector which is pointing towards the other point which is A. That means initially what I need is vector BC and vector BA. Now if I wish to write vector BC, then it is the position vector of C minus position vector of B. You should note it down. If we have BC vector, it is the position vector of the later point minus position vector of the former point. बाद वाले में से पहले वाले का subtraction. So it is OC, wherever is O hardly matters. That means the position vector of C, which is I cap plus 5j cap plus 5k cap. Minus position vector of B, which is 2i cap, 3j cap and 5k cap. Perform the subtraction. I cap minus 2i cap, that makes it minus of I cap. 5j cap minus 3j cap, that makes it plus of 2j cap. 5k cap minus of 5k cap, that makes it 0k cap. If it is 0, write it also, so that while writing it or while using it, you are left with no doubt that k component here is 0. So this is how we have generated vector B. You can do it directly also. We can perform the subtraction in the reverse order. 1 minus 2, which is minus of 1 attached with I, plus 5 minus 3 is 2 attached with J, and 5 minus 5, which is 0 attached with K. Now likewise, we will generate vector BA, which is vector pointing from B towards A. This I am going to do directly as I told you for this one. It's a later point minus the former point. So 1 minus 2, which is minus 1. So which is, this becomes minus of I. 1 minus 3, minus 2. So minus of 2 of J. And 2 minus 5, that makes it minus 3 of K. So this way we have written vector BA also. Now remember, area of triangle ABC. Area of triangle ABC is half magnitude of the cross product of BC vector with BA vector. You should remember this formula. This is standard formula. Cross product of two adjacent vectors, its magnitude, and then divided by 2. That makes the area of this triangle. Now, half remaining the same, BC cross BA can be obtained. We'll be looking for magnitude of this entire thing. So initially, we'll be writing BC cross BA. To write BC cross BA cross product, the very first row of this determinant should be occupied by unit vectors I cap, J cap and K cap. For BC vector, the scalar components are -1, 2 and 0. These are the numbers which are attached with I, J and K. Of course, with due respect to the signs. So it is -1, 2 and 0. And likewise for BA, we have -1, -2 and -3. So this way we have developed the determinant. What we are looking for, this is not determinant sign. This is the magnitude of the cross product. Initially we are writing the cross product. This is BC cross BA along with half. Whatever we get for this one, we will be taking its magnitude. The outer one in blue is what I'm going to write for magnitude of the vector which will be generated when we expand this determinant. So let's work here. Half, it's the magnitude we'll be finding later on. Let us expand the determinant, and you can observe we have I, J and K. I'll prefer writing I cap, put some space here, then minus of J cap, then space, then K cap with some more space here, and then we close it this way because we will be finding the modulus. With I cap, we simply delete the row in the column containing I cap. So we are left with these 4 elements. Product of these two. 2 into -3, that makes it minus of 6. From there, we subtract the product of other two. It is simply 0. So it's 0 to be subtracted. Or minus of this 0, that makes it plus of 0. Hardly matters whether you write plus or minus, but the sign in between should be correct. With minus of J, minus J we have written because when we expanded determinant, it's the second place in the first row, so it has a negative sign. So that's the reason we attach a negative sign. Now this time you delete the row and the column containing J this way. So you're left with these 4 elements. So again it is -1 into -3, that makes it 3. From there we are going to subtract -1 into 0, which is simply 0. Whether you write plus or minus hardly matters because this is also 0. And with K, we have these 4 elements. It is -1 into -2, giving you 2 here. Product of these two. Minus of minus plus. Product of these two. That makes it 2. So it is half here. And it is the magnitude or the modulus of the vector -6 I cap minus of 3j cap plus of 4k cap. This vector is the cross product of BC vector and BA vector. Now if we have to find its magnitude, half remaining the same, half was outside. So magnitude means it is -6 whole square, that makes it 36, plus -3 whole square, that makes it 9, and 4 whole square makes it 60. Right? So 36 plus 9, 45, 45 and 16. That makes it 61. We have 36 and 9, 45. 45 plus 1, 6. That makes it 6 and 5 makes it 11. So it is 61. So what we get is root 61 divided by 2. Since we are dealing with area, don't forget to write the units as square unit. So this way, when we have to find area of a triangle whose vertices are given, then the very first thing you should do is to generate the vectors representing the adjacent sides. Once the vectors are generated, you go for the cross product. Once you have the cross product, you go for the magnitude of the cross product. And finally, since you are dealing with a triangle, you need to divide by 2 every time. This is the standard formula and it should be committed to the memory. So this is again very important question from board's point of view. So over to question number 6.